Whether you're looking high, low, or somewhere in between, you will find life. Here on Earth, it's abundant. And as far as we know, it's unique. We haven't yet found it anywhere else in the universe. So what is the origin of life on Earth? How did life begin? One hypothesis holds that life arose from inorganic, non-living matter more than 3.5 billion years ago. It's known as abiogenesis. This idea proposes that the building blocks of life came together in the chemical soups of Earth's young atmosphere. I met with groundbreaking cardiovascular physiologist and evolutionary biologist Dennis Noble to talk about life. What's your view on abiogenesis?
Very interesting question. I don't think we know the answer to that. First of all, we don't even know whether life arose on Earth. There are, as you know, cosmologists who think that it may be that particles of organisms, particularly very tiny ones, viruses and bacteria, could travel through space. I don't know whether that has happened or not. All I can say is that we do not know, if we're honest with ourselves, whether life originated on Earth or elsewhere, and we certainly at the moment have very little knowledge as to how it happened. What we can be sure of, though, is this. DNA as a system can't have been there at the beginning because it depends upon the whole cell to be readable, for it to have functionality.
Our DNA contains a code, a blueprint for building the proteins needed for life. But DNA itself depends on proteins in order to form. It's a bit like the famous chicken and egg problem. As the philosopher of science Karl Popper put it, the code cannot be translated except by using certain products of its translation. But setting aside how DNA came about, how is its code understood? Do codes mean anything on their own?
From knowing the letters of an alphabet, which is what essentially that DNA sequence is, you can't say that from that alone you understand what is said in the language. Let me just give one example. One of the languages I struggled to learn at one stage was Korean. I could learn the letters of the alphabet very quickly because they're very logical. It's an extraordinary invention done about 500 years ago by King Sejong and his scholars. Each character in the alphabet that the Koreans use, their own, not the Chinese characters, has a shape that corresponds to the shape of the mouth as you speak, which is beautiful. I can teach anybody the Korean alphabet in an hour. But having learned that alphabet, could I understand a novel in Korean? No, not at all.
So if DNA, much like a language, needs to be read and understood in order to function, it seems we need to look into what makes this understanding possible. Some think that information theory may hold the key.
Information theory is an emerging part of science, and it's based on things like, for example, the DNA of heredity and human heredity. DNA is actually a code for building proteins and building organic bodies. So you can't understand what DNA is just by giving a list of chemical constituents that it's made up of. You only know what it is when you know what the code is and why that code builds these particular elements. And that is an amazing fact, which means the information seems to be a non-physical, information is not physical, really, but it seems to be a non-physical constituent of the physical.
To find the origin of life, we've looked at DNA, and now it seems we need to look a bit further, for the origin of the information within DNA's coding. Could that be the trail we need to follow to find the key to life? I think the answer may still be a bit further down the road. We're on a quest to find answers, and this is only the beginning.